A ball is thrown vertically upwards with an initial speed of 20 meters per second. 1 second later, another ball is thrown vertically upwards from the same point with an initial velocity u meters per second. The balls collide after a further 2 seconds. Show that u equals 17.75. Okay, that's interesting. Now, you've asked the first ball, we'll call this ball A. Now, u is equal to 20. B, we haven't got a clue. A is equal to minus 9.8 because it's minus gravity. S equals, the distances are the same, so let's just call it S. S1 equals S. Okay, and then T1. Is this ball in the air longer or shorter than the other one? Longer. How many seconds longer do you think? What ball is thrown for the same point? So, it's only there 1 second longer. Okay? So, 1 second later. So, actually guys, we know the whole time, don't we now? Because this one is 3 seconds in the air. Because it's thrown up, a second later the other ball is thrown, and then 2 seconds later they collide. So it's just 3 seconds total for this ball here. And what will ball B? U equals U. B we don't know. A we know is minus 9.8. S we know, S2 we know is does S, and T2, 2 seconds. Now, make a decision on what formula you think you're going to use. Okay, and why would you say that? S equals ut equals half at squared? We don't know V, so we're going to go with S equals ut equals half at squared. So, S equals, we'll do for B at the moment. So S2 technically speaking, using the red writing. So we're going to go 2u minus a half of gravity, 4.9 multiplied by 2 squared. S2 equals 2u. What's 4.9 times 4? 19.6 minus 19.6. Okay, that part done there. Now, what about S1? Why is it 2u? ut plus a half at squared. So it's going to be u multiplied by 2 plus a half of minus 9.8 times 2 squared. And then that all breaks into that. Okay. For the other one, S1, what we're going to get here is 20 times 3 minus 4.9 times 3 squared, and then we're going to get a 60. What's 4.9 times 9, anybody?
Yeah, 44.
Was it?
Yeah, 44.
Fair play. And then take them away from each other. 15.9. Now, what this means now, guys, is that 2u minus 19.6 equals 15.9. 2u therefore equals what's 15.9 plus 19.6?
37.5.
Yeah. And then what's half of that?
17.75.
There you go. Provided I haven't made a mistake, that is exactly what it is. And guys, how would you rate the difficulty of that question compared to what we've been doing recently?
19.75.
What?
36. It should be.
That's 36.5. Oh wait. It's not 36.5. Well, somebody add 15.9 plus 19.6 for you.
35.5.
What?
5.5.
It's 35.5. And when you have 35.5,
17.75.
you're on the entire video. Now, next part, okay, is find the distance travelled by each ball. Now, do you see what I'm getting you on there, guys? Didn't ask for displacement. They asked for distance. Okay, now that's tricky. So, the problem with that is, there's two scenarios. Okay? Find the distance travelled by each ball before the collision, given your answers correct to the nearest meter. Now let me tell you why this is tricky. Okay? So, what happens is, so what happens is this. What I say was, so we have no new information, okay? There's three scenarios where two objects can hit each other, okay? And the three scenarios are this. Basically, a ball can be on its way up, as shown, and the second ball comes in and hits it as it's still on its way up. For this to happen, U2, which is the second ball's speed, has to be greater than U1. And in this question, this is not the case because 17.75 is slower than 20. Okay? Second scenario is the first ball is on its way down and the second ball is on its way up. In a scenario like this, what we have to be very careful about is calculating the total distance it's travelled. Okay? So what we need to be very careful about is the fact that the first ball while the displacements are identical, the distance travelled are different. Because ball 1 travels up a certain distance and then travels down a certain distance. So it's made up of two individual distances, while the second ball only is made up of one distance. Okay? So where do you think the easy marks are? Ball 2 has easy marks. So we're going to do ball 2 first, because it's going to hit it on the way up. Okay, and it's easy marks. Okay?
Do you know how they're both falling down then?
Sorry?
Were they both coming down in this circumstance? 9.8 divided goes twice.
Oh yes, scenario 4, yeah. That could easily happen, alright? Now, I think what happened there is, if you had a scenario where this one is a distance, okay? And this one stops and is starting to fall downwards. Okay? And what you're saying, that the other one's on its way up or the way down?
On its way down.
Now, the problem is with that is, because they both have the same acceleration, it will never actually catch up, because they're both undergoing gravity. Okay, so that's probably why I didn't think of it, but it's still a good thing that's in the box. Now, so what we have here, guys, is S2. Now, S2 is going to be, U is 17.75, and we have to find out what this displacement is. So once again, guys, we're going to go for UT plus a half AT squared. Okay? So UT plus a half AT squared. So, we're going to get here is S equals 17.75. Now, we know the collision time is 2 seconds later, so we're allowed to still use that time. That's UT, and then plus a half AT squared, which is going to be minus 4.9 times 2 squared. Now what happens when we put that into the calculator? What do we find out for S? And we know, just put it all into the calculator. What do we get?
15.9.
15.9?
9.
Okay, perfect. We had that already, didn't we? I worked that out earlier, actually. So, S2 covers 15.9. Round it off to the nearest meter, 16 meters. We'd actually lose 2 marks if we didn't do that. Okay? Now, next part after that, I'm going to break up A into 2 distinct parts. The first part of A is I'm going to say its velocity is 0. The minute I say its velocity is 0, what do I have to say about the time? I don't know it anymore, because I don't know how long it takes to get to its top and back down again. So T is no longer 3. Remember, T was 3 because it goes all the way up and then back down again. Okay? So that's not the case this time. So what we're going to look at is this. We're going to come in here. We're going to alter that 3. We don't know what it is. We don't know what S is. So we're left with U, V and A. What would be a good idea for this one? what formula could I use? Now, give in mind that I'm looking for distance. I have phi, u, and a. So, phi squared equals u squared plus 2as. 0 equals 400 minus 19.6s, whatever s is. S is how far does it rise into the air. Okay, so anybody tell me that? So it's going to be 19.6 equals 400. And what's s going to be then?
20.408.
20.41 for the time being. Now, because when you look at this here, okay, that's your distance, okay? Now, the other thing is, what happens, we know that the collision takes place 15.9 meters above ground. So, this part here is 15.9. The maximum height is 20.41. Can anybody tell me what this height is here?
20.41 minus 15.
Exactly, take them away from each other. And what happens when you take them away from each other? So we're going to do 20.41, take away 15.9. What you get there?
4.51.
4.51. Now, this 4.51 is distance that your first ball covered. Add them together and what you get? 24.92, and we round that up to 25 meters. The first ball covers 25 meters, yet the second ball covers 16 meters. Okay, so that's it.